In today's video, we'll be doing a complete tour of my home network and smart home setup, because it's not something I've ever really done. I've done an absolute ton of videos of different network things I've set up and different smart home systems I've installed, but I've never done a video showing it all in its entirety. And also, with my impending move, all the stuff's ultimately going to have to be disconnected and packed up very shortly. So I thought it'd be nice to do a final tour of how everything is set up and the sort of stage I got to, both because people might find it interesting, and also just for my own documentation, just so I can kind of remember all this. So what we'll do in this video is, first of all, we'll take a look at all the networking stuff, and then I'll go around and take a look at all the different smart home systems I've installed. Most of the things you'll see in this video will already have a dedicated video on my channel showing them in much more detail, so I'm not going to go into too much detail on everything. I'm just going to go through, summarise everything I've got, and if you want to find more information about something, there'll be a dedicated video on my channel. Unfortunately, YouTube only lets you put 5 cards on a video, so I can't put a pop-up card for every single thing to link to its relevant video, but if you dig through my channel for the videos for the last few years, you should be able to find what you're looking for. So first of all, let's start off the tour at the core of the network. And that is my network comms cabinet in my hallway cupboard. This cabinet holds sort of the core of my network, so everything that's essential for the network operating day to day is in this cabinet here. And as I mentioned, this is in my hallway cupboard. Throughout my flat, I've got an absolute tons of Cat6 network cable runs, about 23 from memory, need to double check. And all those runs come back to this cabinet, where they're connected to this patch panel at the top. This cabinet then contains all the network hardware for connecting all the devices around the flat to the internet. So if we go through one by one, we'll see we obviously have the patch panel, so this is where all the cable runs terminate to. Most of these connect to the switches in this cabinet, but some of these are also patched together directly. So the ones that have purple cables are essentially 2 ports in this patch panel plugged directly into each other to create point-to-point links between 2 ports in different rooms. And I use this for HD-based video distribution that we'll take a look at later. Next up, we have my firewall, which is this machine here, which is an Intel Atom C3558R CPU-based little embedded firewall. It's a great little device, and on this I'm running OpenSense. Into this we can see we have the green WAN cable that goes up to the patch panel and connects to my modem, which sits off to the side, it's mounted on the wall. And that brings my 300 megabit GFast connection into the firewall. GFast is a weird technology that's not really installed nowadays, but it's the fastest connection available in this building, where it's a copper to the premises connection, fibre to the cabinet. It's almost like a DSL type of connection, except because I'm very close to the cabinet, it can go up to about 300 megabit down, 50 up. So it's DSL, but still pretty quick. So that's what I use as my internet connection here, and that goes into the firewall. Then coming out the firewall, we can see we have a SFP plus DAC cable that goes down into the first switch, and then that switch connects off into the second switch. And these switches are from the Cisco business line. This is an interesting product range from Cisco that sits sort of below their higher end Cisco Catalyst switches, which are running Cisco iOS. And instead of running iOS, run their own sort of embedded software. So while they aren't running full iOS, they still have a fairly iOS-like CLI, they're still fully managed, they've got decent layer 3 functionality, and the benefit of these over using Catalyst switches in a home environment is these don't require any sort of support contracts. You don't need to get support contracts for firmware updates, things like that. You can just download the firmware directly from Cisco's website, which is much better for a home environment or small business. The top switch we have here is a CBS 350-12NP-4X. This has 12 multi-gig PoE ports, so these ports can do 100 meg, gigabit, 2.5 gig and 5 gig, and also output PoE. And then for uplink, it has 4 10 gig ports. 2 of those are just SFP Plus only, and 2 of those are combo ports that can either be SFP Plus or RJ45. So for the uplink, I'm using 2 of the SFP Plus ports, one to uplink to the firewall, one to uplink to the switch below, and I'm using one of the copper ports to connect over the structured cabling to another 10 gig switch in my office that we'll take a look at in a minute. Then all the devices plugged into this switch are either devices that require PoE or require multi-gig. So for example, my access point, that's PoE and 2.5 gig. My cameras are only 100 meg, but they require PoE, so they're connected into this. And then any other devices, for example, where I've got some network ports that I might connect to a machine with a 2.5 gig NIC, they're also connected into this switch. Being from the 350 line of switches, this also has quite decent features for layer 3 routing and all that kind of stuff. I'm not really using any of that though, but it does have it. And then for the switch below, we have a CBS 250-24T-4X. And this is just a fairly standard gigabit switch, 24 port gigabit, non-PoE, but it does still have 10 gigabit uplinks, so it's still uplinked to the rest of the network at 10 gig. And this just connects to all the other sort of general basic devices I have. So things like TVs, gigabit desktop PCs, smart home devices, all that sort of stuff connecting to the switch here. It's just because that multi-gig switch didn't have enough ports, so I added that one in there. Now this is from the 250 line of switches, which is a bit lower end. It's still fully managed with a CLI and all that sort of stuff, but doesn't have quite the same amount of layer 3 functionality that the 350 series has, and unfortunately it can't be stacked with a 350. The 350 switches can, with 10 gig uplinks can all be stacked together. I can't stack this 250 with the 350 above, but I got this for such a stupid price. I think I paid around about £200 or something for it. It was a silly low price. It made sense just to go for the 250 series just because of that price difference. So that's what we have there, and that just connects to much more basic devices. For power below that, we just have a standard PDU. This is just regular 13 amp sockets. Generally in server racks, I tend to use ones with IEC power outlets, but especially historically in this, I've had like power bricks and stuff plugged into this, so I use this instead. And this just comes out the bottom of the cabinet here through a stuffing gland. The cable runs around the room and just plugs straight into a socket, so that's all fairly simple. The only other device we note in here is this little Dell Optiplex machine you might see up here, and this is a Dell Optiplex 5070 Micro, and this is my blue Iris NVR for my cameras. So this is just a little basic Dell Optiplex micro form factor machine. I think it has an i5 9500T CPU if I remember, I think 8 gigs of RAM, and it's just got a little 1TB 2.5 inch hard drive in it, and runs Windows 11 and Blue Iris. And this handles the NVR for all my cameras. And the reason I have it in this cupboard is because this cupboard automatically locks when I arm my alarm system. We'll take a look at that later. So I wanted to put the NVR in a slightly more secure location in here, so if someone did break in, this cupboard would be locked, and then they wouldn't be able to get to the NVR. So that's why that's up there. So yeah, that's it for the comms cabinet in the hall cupboard. And essentially this is everything for the network to be operational. Any other network device around this place could all be switched off, disconnected, and the network would stay up. So this is just the core of the main network. So what we'll now do is take a look at the second server rack I have, which is in my office. So next up here in my office, we have my second rack. And if people are wondering what the model of this rack is, it's a ZPAS SJB. So ZPAS is the brand, and then SJB is the model. But unfortunately, you can't really get this nowadays. Every time I show this in a video, loads of people ask about where they can find it, but it doesn't seem to really be available for sale to the regular public. The company still exists, and they do list this on their website, but I can't really find anywhere that stocks it. So you may be able to contact them and do a sort of special order, but it's not just the sort of thing you can easily buy retail nowadays. Which is a shame, because this is a really nice little rack that you can have in an office or in a room that doesn't look too sort of industrial or sort of ugly. It's not the prettiest thing in the world, but it's pretty nice. And if we open this up, we can see what we have inside. So I made a video about this rack before, where I soundproofed it and added a cooling system. In that video, I added this acoustic foam to the inside, which is also very fancy fire-rated foam. I think this is even rated to be used in like engine compartments, things like that, so it's basically completely non-flammable, because I didn't want to have flammable acoustic foam surrounded by servers and electronics. And then in that same video, I added a cooling system, which consists of a 120mm fan in the top and a 120mm fan in the bottom, controlled by this AC Infinity fan controller. And unfortunately, they also don't seem to make this fan controller anymore, which is a real shame. Because unlike most of these rack mount fan controllers that are just a thermostat, this one can actually speed control the fans based on the temperature. So if the rack starts heating up, the fans will slowly ramp up in speed, which is a lot less disruptive than having a thermostat where the fans might be clicking on and off, and you'll notice that. Whereas you won't really notice the fan just sort of slightly speeds up. So this is really good. So this is what I have for the cabinet and the cooling system. And whereas the cabinet in the hall cupboard contains the sort of core network equipment, this on the other hand contains servers. And it's located in my office really just because there's no other space for it. It would be great to have everything in a single cabinet, but unfortunately the hall cupboard just doesn't have the space for that, because it's also required to be used for like storing an ironing board, boring stuff like that. So I couldn't have a full-size cabinet that could fit servers in that cupboard. So that's why this sits in my office. First of all, in terms of networking equipment, we can see down here we have this switch. And this is another Cisco business switch. It's a CBS 350-12X. And this is a 12-port, 10 gigabit switch, where it has 12 10 gigabit base T ports. The last two are combo ports, so those can either be 10 gig base T or SFP+. And this connects everything in this cabinet together. This yellow connection here connects into a wall port, and that runs over to the multi-gig switch in the hall cupboard with a 10 gig link, so that's the uplink to the main network. And then all these ports connect to other devices. So they connect to either servers in here, management controllers in here. I think my printer plugs into this as well. And then I have a 10 gig NIC connected to my docking station, and that also connects into this switch. In terms of servers in here, Only 2 of these are in active use. The first one is this 2U box here, which is my TrueNAS box. This is based around a Xeon D CPU with 10 gig uplinks to the main network, and it has a bunch of 2.5-inch SATA SSDs, so it's fully solid state storage. And that runs TrueNAS, and that's my main storage. So it stores all my sort of general day-to-day documents, all my completed YouTube videos, thumbnails, all that sort of stuff. And then sometimes I also use it to store raw footage for videos that I'm not planning on releasing for a while. Generally for videos I'm filming and editing in the same day, I just work straight off the camera at the SSD that connects to the camera. But if I need to store footage for a longer term, that also gets stored on this machine. And this then backs up off-site every week, so I've got an automatic off-site backup. The second server we have is this Asus one here, which is an Asus RS100 E10PI2. And this is a little 1U machine based around a Xeon E2274G CPU. It's nothing particularly fancy, it's a quad-core chip, maybe 1 or 2 generations old. It's got 16 gigs of RAM, and I think about a terabyte of RAIDed NVMe storage, so there's a pair of NVMe SSDs there in a mirrored RAID configuration. And this is my Proxmox server. So this runs Proxmox V, and it hosts all the sort of applications that I need to have on my local network. Mainly my smart home stuff with Home Assistant, Node-RED, various things like that. It also hosts things like Bookstack for documentation, PHP IPAM for IP address management, and Heimdall to provide a sort of homepage dashboard sort of thing. One day I'll do a full video documenting all the applications I have on my home server, but for all you really need to know now is that Asus server there is just my Proxmox host, and that hosts all the applications I need on my local network. The next 2 servers you see aren't really being used. We've got this 4U machine here, which is I think a Xeon E3 based machine. That's my old NAS, I don't really use that now. And then below that is a 2U case that I think has a motherboard in it, but most of the parts have been nicked out of it over the years. I just really need to get rid of that, it's just been sitting in the rack for ages. I should probably just get rid of it. And then finally down the bottom, we have a 1U PDU. So this is an APC individually switched PDU, so I can easily switch on and off all the outlets, and that's it sitting there, so that's connected to the network. I can monitor the total power draw of the rack, and I can switch all the outlets on and off remotely. So if I need to reboot anything, I've got that there. And all the machines connect into that with IEC patch leads. So yeah, that's what we have in this cabinet. And then for wireless connectivity, we have this Ruckus R650 access point. And this is a really high-end Wi-Fi 6 access point. And it's running Ruckus's Unleashed firmware, which means rather than sort of traditional Ruckus access points where you have to have a dedicated controller that costs a lot of money, with Unleashed access points, the access point itself runs the controller, and you can have multiple access points all managed by a single controller running on a single AP. Now with my setup here, I only actually have a single access point. I don't really need any more for this space, it's not huge, but it does mean that I could easily add additional access points as time goes on, and they'd all be managed by the controller hosted on this AP. It's mounted on the ceiling here, and it's connected at 2.5 gig to that Cisco business switch in the hallway comms cabinet, and it's been working pretty well. So that's really all of the network hardware. The final thing we'll really take a look at that's related to that is my living room AV cabinet, and in here we have this additional little 16-port Cisco business switch. This is another 250 series switch, and it's just a standard gigabit 16-port switch, and this just connects all the AV devices to the network. So there's a single link from this to the switch in the hall comms cabinet, and that connects all these sorts of devices up in here. And it's really fine just being uplinked at gigabit, because out of all these devices, I think the vast majority of these are only 100 meg anyway. None of these really require a 10 gig uplink or anything like that, so that's absolutely fine there. And then as for my AV setup, you can see we have a bunch of different set-top boxes, PS4, PS5 on top of the cabinet there, Apple TV, Skybox, all that sort of stuff in here. We then have a Denon AVR X2400H AV receiver that connects everything up to my TV. This also connects to a 5.1 system in the room. And then the other interesting device you might see down here is this Wirestorm HD Base T Matrix. Previously, I made a video about an HDMI distribution system using a fairly cheap HDMI matrix switch. Since then, I've actually picked up this Wirestorm matrix. It's a much higher end matrix, it's 8x8, it's HD Base T rather than sort of generic HDMI over Cat6, and I've been playing with it, and it works really well. I've just not had a chance to make a full video on it yet, but after my move, I'll be doing a dedicated video installing this in the new house. And this is a really high-end 8x8 HDMI matrix. So this distributes video from all these sources in here to all the TVs in other rooms. So for example, I can have the Apple TV playing in the bedroom, or I can watch Sky in my office, or more usefully, I can have the same thing playing on all the TVs all at the same time. So if I'm walking between rooms, say I'm cleaning up or packing or doing something, I can put something on and have it playing across all the TVs simultaneously. This works really, really well. Now it's important to bear in mind that HD Base T is essentially HDMI over Cat6 cables. It's not HDMI over a network. So this doesn't work through any kind of network hardware. This requires point-to-point Cat6 links between the matrix switch and the receiver behind each TV. So if you look down on the wall here behind the cabinet, we can see we have 4 network points. One of those connects to that switch, and then the 3 on the right-hand side, you can just about see the HDMI labels, or the labels above labeling different rooms. These are point-to-point links that go from here directly to behind the TV, and they're essentially patched together on the patch panel. And then behind each TV, I have one of these HD-based T receivers, and this takes the video from that HDMI matrix switch and connects it to the TV over HDMI. So all my TVs have one of these, except the TV in the living room that's connected to the receiver directly with an HDMI cable running through the wall. Then in the living room for audio, I have a 5.1 setup. So as you can see down here, we've got a bunch of speaker binding posts on the wall, and these connect to various speakers around the room. For front channels, I have these Monitor Audio Bronze 50s, which are wall mounted. These sound absolutely brilliant. For the center channel, I have this Monitor Audio Bronze C150 center speaker, which is mounted below the TV. And then for surround channels, I have these Monitor Audio FX speakers, which are mounted on the wall. And these are absolutely brilliant because they're so much more discreet than having big bookshelf speakers behind you. And they also disperse the sound really nicely as surround channels, so these work really, really well. So there we go. That was a look at the home network and AV side of things. So what we'll now do is go away and take a look at the smart home system. So for the smart home side of things, I have a couple of main design philosophies. And that is that it should kind of augment my life, but not be obtrusive, not be confusing or require a lot of learning. And also if I have guests over, they don't need to try and figure out how things work. So that means I don't have things like voice assistants or weird commands you have to use or have to rely on an app. I'm quite focused on having physical controls to control everything. I also want to avoid reliance on cloud services, so wherever possible, everything here is locally hosted and based around Node-RED and Home Assistant. And here we can see one of the main areas you'll see the smart home, and that's these little in-wall touchscreens. These are little in-wall Android touchscreens, they're little sort of 4-inch screens, and these are displaying my Home Assistant dashboards. But for me, rather than trying to build Home Assistant dashboards that are absolutely huge, chock full of information on one big page that works on a desktop or a tablet, my Home Assistant dashboards are a lot smaller and split over lots of separate pages that you can then navigate between. So these are little link buttons that navigate between different pages, so you can press that takes you out to the room menu, you can go into different sections in here. And the idea is that these Home Assistant dashboards are really easy to use both on these little in-wall touchscreens or on a phone. You don't need to have a tablet with a big screen, they work perfectly fine on a phone or these touchscreens. And here you can see one of the main areas that I focus on with my smart home, which is lighting control. So several of my rooms have these touchscreens, and all of those by default show this lighting control screen, which lets you pick between different lighting modes. I can pick warm, cool, night light, colourful, so I can change the colour temperature, how bright they are, or set different colours. All the lights are RGB smart bulbs, we'll take a look at those in a minute. I can also adjust the brightness with the brightness control there, or adjust the colour temperature. If I go out to the room menu, I can pick different colours on the colour wheel if I want to do RGB, and all that sort of stuff there. I've also got an option for the Christmas tree here. When I had a smart Christmas tree, I've just not removed that, but every year that will be used to control the Christmas tree. I think for right now it won't show anything because the Christmas tree is not connected. What I can also do is go out into the main menu, which lets me pick between different rooms. So if I want to, for example, control the bedroom lighting from the living room or vice versa, I can easily do that. I can also control things like the robot vacuum cleaner and the alarm system. That's all controllable from these in-wall touchscreens or the mobile app. And then if you leave these touchscreens on a sort of non-home page for a long period of time, say you leave it on this menu or the lighting control for a different room, after I think 30 seconds or so, it'll refresh and then load back up the lighting control page for the room that it's in. So you can never accidentally leave it on the wrong thing. You can come in, interact with it, and then you go away, and when you come back, it'll be sitting on the screen, ready to control the lighting in the room. Because what I want is to be able to walk into a room and then very easily change the lights using this touchscreen. These touchscreens can also control the AV system. So for each room, I can turn the TV on and off, and I can also change the input through the HDMI matrix switch. So I can very easily come onto this and control this AV setup within each room. In addition to the touchscreens, I'm also a firm believer in having physical switches for controlling lights. One of the main gripes I find with when people have smart bulbs is when they have normal light switches on the wall that they permanently leave on and you're not allowed to touch them or you break the smart lights, and you've got to instead walk into the room, remember not to touch the light switch, and instead ask a voice assistant to turn the lights on and off. That always drives me mad. But likewise, while the touchscreens are great, they're not amazing as just a standard light switch, because you've got to walk into the room, find the touchscreen, find the button on it and press the button. There's just something nice about having a physical switch on the wall where you know where it is and you can easily hit it. You can hit it with your elbow if you need to, and if you have guests over, there's no confusion about how to turn the lights on because there's a switch on the wall. And in fact, these switches even say press on them. It's very obvious how to work the lights. So what I have for this is behind the switch, I have a Shelly device, which is just a little Shelly Wi-Fi relay, and that's connected to this retractive switch. So being a retractive switch, it springs back, it doesn't latch in either positions, it's just a press switch. If I press it, it'll turn the lights off, as you can maybe see by the picture getting darker, and if I press it again, the lights will all turn back on again. Because the room has smart bulbs, the Shelly keeps the bulbs permanently powered on. So all the button's doing is just telling the smart system to turn the smart bulbs on or turn the smart bulbs off through Home Assistant and Node Red. But because the Shelly also has a relay that is connected to the smart bulbs, this also adds a very nice failsafe. Because what this is set up to do is that if the smart system goes down and the Shelly cannot connect to the MQTT broker, the Shelly will then act like a standard relay. So when I press the switch, it will kill power to the bulbs, and when I press the switch again, it will turn the bulbs back on again. So that means that if the network goes down or the smart home system, Home Assistant, whatever goes down, this switch will revert to being a standard physical switch, so it will turn the lights on and off by switching the mains power. So that means that in the event of an outage, I can still control the lights. I also have an override on this, so that if I hold this switch down for I think 10 seconds, it will kill power to the bulbs, and if I press it when the bulbs have power killed, they'll turn on again. That means that even in the event that, say, the smart home system isn't quite working right, but the Shelly still thinks it's connected, I still have the ability to cut power to the smart bulbs. I don't have to rely on Home Assistant. The Shelly also gives really useful functionality for dealing with power cuts. Because one issue you might have found if you've got smart bulbs is that if there's a power cut and the power comes back, more often than not, most brands of smart bulbs will turn themselves on. And that's not fun, because if you have a power cut during the night, you might wake up to all your lights suddenly turning on when the power comes back, which isn't great. So with the Shelly, what I've configured is that if it turns on from a power cut, it will keep the smart bulbs powered off. And then the first time the switch is pressed, it will then turn them on. So that means that in the event of a power cut, I won't suddenly wake up to all the lights turning on. They'll only turn on when I've pressed the switch for the first time. So these Shelly devices are absolutely brilliant for setting up this sort of smart switching. Even in a setup like this, where I'm not actually using the Shelly generally to switch lights on and off, I'm using the smart bulbs and the Shelly is just an input to that, having that additional relay in there makes it really useful as a sort of fail-safe or override for those sorts of situations I've just described. So yeah, that's my light switch setup. So now let's quickly take a look at the lighting control in practice. So in this room we have a bunch of downlights, there's 9 downlights in total, you can only see 3 of them, and there's also a lamp in the corner there and a couple of other lamps around the room. And if I press the switch on the wall, you'll see all the downlights turn off, as do all the lamps. So I don't need to go around and turn them all on, I come in, press the switch on the wall, and all the lights in the room turn on. I can then go through different scenes, for example if I switch to the cool colour temperature, that'll turn all the lights to a cool colour temperature. If I set it to warm, that'll go to a warm white, and then it'll dim the first two rows of downlights down a little bit so it's not quite as harsh. If I press night light, all the lights will dim down really low and go to a really warm colour temperature. They might not even be really showing up on camera. Or what I can do is go to colourful. So if I press the colourful button, all the lights will turn to RGB colours. So there's a mix of different colours here. I can go into the room menu, go into the colour section, and I can change what colours the lights are. I can make them red, for example, and all the lights will change colour. So you can change that one there, and then maybe say, change the other ones to green. And there we go. So I can have the lights as RGB, I can then go back to the room menu, back to lighting, press warm, and all the lights go back to normal. It's really, really flexible and really easy to use. And I vastly prefer this to having to take out a phone to use an app or talk to a voice assistant. I can just walk into the room, decide what lighting mode I want, and just press the button on the wall to get the appropriate scene. So there you go. That was a look at the smart lighting setup in rooms where I have smart bulbs. And smart bulbs are great for situations where I want to be able to change the colour temperature, or change the colour, or control each different light individually. But I don't need that everywhere. For example, in my hallway, where I do want smart lighting, but I don't really need to have all the bulbs individually addressable. All I really want is the ability to automate the lights, and also have the light switches on the wall control things like lamps or a bookcase. So for that, I'm using a Shelly dimmer. So I have a Shelly dimmer installed behind this switch here. This originally was two-way switching, so there's a switch by the front door and another switch by the living room door. And these are both now wired up to a Shelly dimmer. They're replaced with retractive switches. So if I press that, the lights will turn off. If I press it again, the lights will turn on. And then if I hold that switch, it'll dim them. And then if I have the lights off, for example, and then I hold this switch down, you might not be able to see, but the lights will come on a much lower brightness. If I then double press it, It'll turn on to full brightness, so I've kind of got a nightlight feature, and it's really, really nice to have, and I can have smart lighting, but still just use normal bulbs. I don't need to have smart bulbs in all the fixtures in this room. One of the main uses for the smart lighting in here was because I have this bookcase, and this has an LED strip in the top, but it's not connected into the main lighting circuit. It's just got a permanent live supply. So I wanted a way to switch this on and off with the same light switches that control the lights in the hallway. So I've got that set up. So this LED strip is connected to a Shelly RGBW LED controller. It's not an RGB LED strip, it's just a white LED strip, but that Shelly RGBW can be used as an LED tape controller. That's linked into the Home Assistant in Node-RED, so when I control the lights in the hall, you'll notice that the LED strip will be controlled alongside them. So if I turn the lights off, the cabinet turns off. If I turn the lights on, the cabinet turns on. And likewise, the cabinet dims up and down along with the rest of the lights. And that works really, really nicely. I've also been able to add slight integrations with the hallway lighting. For example, it's integrated with my alarm system. So when I come in from outside and the alarm's doing its countdown, so it's beeping and waiting for the code to be put in, because it knows essentially that I've walked in from outside, it will automatically turn the hallway lights on. Likewise, if I arm the alarm system and I leave, all the lights, including the hallway, will automatically turn off. So that's really useful. Now, I'm not a big fan of overly complicated automations. You know, I see people doing stuff about, oh, when I walk into this room, the music plays and then this turns on and stuff. I don't want that, because as soon as you don't want it to do that thing, it becomes really annoying when lights are turning on automatically or turning off automatically, or TVs are controlling themselves. I'm not the biggest fan of having a lot of excessive automations, but this is one automation that's very simple. And generally speaking, anytime I'm coming in from outside, chances are I want the lights to come on, because this hallway without lights is really, really dark. So that's the sort of automation I've got set up there. The final device I have in my smart home is my alarm system. And this is a Texecom Premier Elite Burglar alarm. And I've got this integrated with Home Assistant in Node-RED. I made a video showing this in full detail, but essentially what I have inside this is a little UART to Ethernet adapter. So it's a little serial console server that's connected to one of the serial ports inside the alarm panel. I then have a Node-RED flow created that integrates with the alarm system to allow me to view its state and also control it. I use this for a bunch of different things. It lets me, for example, arm and disarm the alarm remotely. If the alarm goes off, it uses Twilio to trigger a phone call, so I get a phone call notifying me that the alarm's gone off. And I can also use it to automate various things in the home. As I mentioned earlier when I was talking about the hallway lighting and how the hallway lights come on when the alarm is doing its countdown after you enter the house, that's one of the integrations. But the other really useful integration I've built is that this is integrated with my Nest thermostat. So when I arm the alarm system, the Nest thermostat will turn off, so the heating will turn off. When I come in again, the heating will turn back on. And then of course, if I'm away from home, the Nest will have been turned off, but I can easily go back into the Nest app and turn the heating on again, so I can easily turn the heating on when I'm on my way home, but it also means that heating just automatically turns off when I leave home and turns on when I come back, which is a super useful integration. I can never go away on holiday and forget to turn the heating off. So I thought as one final demonstration, let's take a look at this working. So what I'll do to try and demonstrate this is I'll set up the camera filming the Nest thermostat, I'll then arm the alarm, you'll hear the alarm arming, and when the alarm arms, you'll see the thermostat will turn off. And then when I disarm the alarm again, the Nest will turn back on again. So let's take a look at it. Okay, so here we have the Nest thermostat set up. So what I'll now do is I'll go away and arm the alarm system, and you'll see that the Nest will automatically turn off. So come in here and I'll arm the alarm. You'll hear the alarm doing the countdown. And once it arms, the Nest will turn off. Give it a couple of seconds. And as you can see, the Nest is turned off. So the heating is now automatically turned off because it thinks I'm away from home. And now if I disarm the alarm system again, and then disarm, you'll see that the heating will turn back on again. It works so well, and this is such a useful integration to have. So there you go. That was a complete tour of my home automation and home network setup, and hopefully you found it interesting. It's one of those things that very much evolves over time. This looks completely different to how it looked when I first built it all, so it's really interesting seeing how it's evolved. And before I take it out for all the house move, I thought I would do one final demonstration of exactly what I have set up. Because the next time you see this, I'll be taking it all out and preparing for moving. And then after that, we'll be taking a look at a lot of very interesting new things I'll be doing in the new house. But all that's left to say now is thank you very much for watching.